Okay, so we're going to find stresses at point A, point B, and point D. Okay, so we are going to we know that this structure is under unsymmetrical bending because you have moment that you can break down into Y and Z components. So let's start breaking down the moments. Okay, so let me. So over here, we know that we have moment along the Z-axis. Okay, so this is due to our mz. Then you use your right hand rule. You know that the moment vector will be in this direction. And then we have also moment about the y-axis. Okay, so this is moment for the y-axis, and this is the moment vector. Okay. So from here we can calculate our moment about y-axis. So moment about y-axis is equal to m, which is 10 times 10 to the power 3 multiplied by sine 20. Why sine 20? Because this angle over here is 20 degrees. Okay, so this is equal to sine 20 times 10 to the power 3 is 3420 pound inch. And then we are also aware that moment in Z is equal to 10 times 10 to the power 3 and cos 20. Okay, so 10 to the power 3 times by cos 20 is equal to 9397 pound inch. Okay, so we got that sorted out. Let me do it again. Cos 20. Yep. Okay, we're good. So if we were to reflect back into the formula, is we have found out what is our IYY or MY. We know what is our MZ. Next, we are going to determine IYY and IZZ. Okay, so next we are going to determine or before we determine, let's analyze what we have by applying our moment vector, right? So MZ on top is compression, right? The head of the moment vector is compression. The tail end is in tensile. On the right, on MY, we realize the head end of the moment vector is compression, and the tail end is tensile. So if you can do this, part of the battle is already won already. You already analyze where is compression and where is the tensile. Okay. So the next thing we're going to determine is we are going to determine our IYY and IZZ. And I'll write out the general formula. Okay. So second moment of area, I, is equal to width depth cube divided by 12 plus by the cross-sectional area multiplied by the global centroid minus by the section centroid squared. Okay, so big Y bar is the global centroid. Global means the entire structure centroid. Okay, That is what we call global. And then small y bar is the section centroid. Okay, so now you can see the difference. Okay, so next we are going to find what is IYY first. Okay, so I'm going to copy the diagram. So we are going to determine, we're going to find IYY. Okay, so we know that the axis, YY axis is over here. Okay, so I'm going to draw the axis. Okay, so this is the axis of interest. Now, where the centroid is, I don't know yet, or we don't know yet. Okay, at this stage, we need to find the centroid. Okay, so we know that when it's parallel to the axis of interest, this is our width. And when it's perpendicular, right, to the axis of centroid, this direction is our depth. That's what we know. Okay, so before we can find IYY, you have to determine we have to determine the location of the centroid. Okay, for this case, you cannot do by observation, unfortunately. Okay, we cannot do by observation. Okay, so I'm going to we are going to call this our section 1. Okay, our section 1. So what we want to find is our small z. Okay, and then this is our section 2. Okay, and we're going to take our geometric datum at the top. Okay, at this end is our geometric datum. Okay, then we're going to generate a table. We have a section, and I will strongly recommend you to apply this technique that I'm teaching to help you find your centroid and your second moment of area, because it is error proof, and I'll show you why. Okay, this is section 1 and this is section 2, and then the next column is we're going to start with width, and then we're going to do depth. Okay, so section 1, the width is 3 plus 3, 6, 8. The depth is 2. So this is equal to 16. And the next one, the width is 2 in section 2, and the depth is 4. So this is 8. So you can see now, by knowing what is your width and depth, is so much easier, right? Or not, it can be a bit confusing. Okay. Then the next one, you're going to find your Z bar, the small Z bar. So the small Z bar, I'm going to draw them in green. Okay, is the individual centroid. Okay, so this is the individual centroid for 1, and this is the individual centroid for 2. Okay, and this can be done by observation, because it's exactly in the middle, and this distance and this distance are exactly the same. Okay, so for Z is, because the datum is on the left hand side, so it's 2 divided by 2 divided by 2, the depth, and then half the depth, so it's 1 inch. And then for section 2 is 2 plus by 4 divided by 2. Okay, so this is equal to 4. Why? Because the distance from here to here, this distance is 4 divided by 2, and the distance from here to here is 2. Okay. If anyone has question, please stop me. Okay, then I will repeat again if it's not clear. Then finally, once you have this, you're able to determine your W, D, Z bar. So this is equal to 16. 8 times 4 is equal to 32. Then you do a summation of your area. So 16 plus 8 is 24. And you do a summation is 16 plus 32 is 48. So your global centroid big Z bar, this is your global now, right? So it's equal to 48 divided by 24. So this is equal to 2 inches. Okay. So this position from the datum to here is 2 inch. Right? Is 2 inch. So this is exactly where the centroid is. Okay. So that is done. So next we want to find IYY. Okay. Oh, sorry. Yeah, we want to find IYY. So IYY1 in section 1, and I'm going to zoom in, okay? And I'm not going to look at the geometry. Okay, we are not going to look at the geometry. But you can just use the table to determine what is your IY11. So how does this work? So we know, okay, I'll show you the general formula. So we know that I is equal to width, depth, cube over 12 plus by the area z bar minus small z bar squared. Let me write this in small form. Or not, it can be very confusing, right? So when I write that, okay, you can see the relationship from the table, right? You can see that this is your width. Over here, the next one, this is your depth. And then the next one, you can see that this is your area. And then you can apply that this is your big Z bar. And finally, this is your small Z bar. Okay. So all these are all available on your table already. Okay. So sorry, I should have pointed the letter. Okay. And this is the cross-sectional area. Okay. So I'll write that this is also equal to your area. Okay. So from here, you can see that we are not looking on our diagram. We just follow the table. So we can determine that IYY1 is equal to 8BD cubed over 12 plus by area of 16 multiplied by 2 minus by 1 squared. Okay. So you will never make a mistake. If you look at the solution manual, they all lump into one working. You can make a lot of mistake that way. Okay. So I'm going to calculate 2 power 3 times 8 divided by 12 plus by 16 times 1. So this is equal to 64 over 3 inch to power 4. Okay. Then I'm going to do IZZ2 again. As you can see, I can't see, oh sorry, IYY2, I can't see the diagram, but I only can see the table. Okay. So 2, 4 cube 12 plus by 8, 2 minus 4 squared. Okay. So 2 times by 4 power 3 divided by 12 plus by 8 times by 2 squared. So it's equal to 128 over 3.